Hello everyone, welcome back. We're going to be looking at the Tech Active paper today from 2021, really to finish off all the 2021 papers. We've got multiple choice tech free, the full tech free short response. We're going to be tackling the short response Tech Active paper today. It's going to be slightly different. There's no way for me to demonstrate the calculator Sorry, I couldn't speak properly. There's no way for me to demonstrate the calculator to you guys, in a separate window. I'm trying to work on that fix. Maybe, hopefully, in a Tech Active video soon. I've contacted some calculator companies. Hopefully, we can figure something out and I can get an actual emulator to show you guys the exact buttons I would press. As it stands, my current actual calculator I use when solving the Tech Active paper is currently at the school I work at. So I don't actually have access to the calculator here, but I have written down all the things I would do and I have all the answers. So this is going to be a little bit different because this is a paper I've actually done all the solutions for just my own class. It was a little bit ago, so there's still a few questions I actually can't quite remember or haven't seen in a while, but I do actually have the written out answers, so I can talk about when we're going to use cross product, things like that. The calculator that I personally recommend is the TI Inspire. In terms of graphics calculators, I think it's just a little bit more effective, although I'm going to use the Casio more throughout the rest of this year, so I'll have a bit of a better feel to see if I still believe in that recommendation, although I think so far from what I've used, the TI Inspire I think is fantastic. So we're doing the 2021 paper. We're going to jump straight into it. The last time I did a full exam, it took 2 hours. We're going to try hard to come in under that, although I feel like with the Tech Active, it's probably the hardest of the two papers. There can sometimes be a little bit more to talk about. So let's jump into question 11. Question 11, we have a triangular-based pyramid as shown. I'm given, essentially it's going to be a 3D vectors question, some kind of geometric 3D vectors type of question. I think there's been similar ones pretty much in every single paper that has ever existed in specialist math. So not a surprise to see it in question 11. It's normally been simple, familiar. There's been a lot of boxes and stuff before. Hang on. Did I miss part A? Where's the actual... Is there not... This is just it. Okay. Use a vector method to determine the area of the shaded face of the pyramid. So we should know that to get the area, that is the magnitude of the cross product. Okay? So I want to start by establishing two vectors on the face of my shape. In other words, I want to find two vectors. I can actually pick how I want to go about it. Just for the sake of making things relatively easy, I think finding A to B and then A to C makes the most sense, right? So we're going to find two vectors. Normally like to join them tail to tail. So AB, AC, CA, CB, something like that is great. I find the cross product of those two vectors. I take the magnitude of that and I find the area for a parallelogram, I should say. Area for a parallelogram. A triangle is half a parallelogram, so I halve that total area. I've got the area of a triangle. So simply just magnitude of the cross product. I have to start by finding vector AC. Well, I got the line drawer on. AC and AB. So if I find AC and AB, I'm just going to put them on the page here where we can see. Of course, if you're in the exam, put your answer in the working out space, but just because I don't have to, because it's not the exam, I'm not scanning this off and marking it. I'm going to find AB and AC here. So whenever we're finding essentially like a position vector, I suppose, right, we do final minus initial. I'm going to put my coordinate points for B first. There is a few different ideas that all get to the same point. I think final minus initial makes the most sense, and it's such a logical tie into so many other things we do. If I now subtract my steps, I have minus 1, that is going to give negative 2. I have 2 minus 2, that's going to give 0. And I have minus 2 minus 5, that is going to give negative 7. I'm going to now do the exact same thing with AC. Again, final point is 0, 5, 2, minus my initial point, which is still A, being 1, 2, and 5. Again, I subtract. 0 minus 1 gives negative 1, 5 minus 2 gives 3, and 2 minus 5 gives negative 3. So I wind up with my two... Oh, sorry, my face is in the way. I'm going to wind up with my two vectors for AB and AC. I now want to find the cross product. Now, there is some ways to use the calculator to get straight to our answer, okay? This depends how good you are with the calculator, because I can't demonstrate all the different, like, the slight variations. We're going to focus mainly on what are the core skills you absolutely must have to function in the Tech Active paper. The Tech Active paper is considered a little bit harder, and part of it's because you can't really brute force the problems in the same way you can in a Tech Free paper. To brute force a Tech Active paper, it's like sort of like just math your way to a solution. You need to have Tech Active skills. You need to also be able to brute force using the calculator. So, To do that, we're going to talk about what are the basic things you absolutely must have. One of them is, because if it's a time-based assessment, is finding the cross product. Yes, you could find it tech-free, but it's a tech-active paper. You don't have to. And again, it's a time-based assessment. We want to do things in the most time-effective way possible. So, to use cross product on the calculator, I might as well write everything on here. I simply do what's called cross. Oh no, it's going to be a little bit hard. I'm going to come across. Wait, I know what I can do. I'm just going to copy and paste this stuff here, which you guys can't do in the actual exam, but I can do. I'm just going to copy and paste everything I've written here. I'm going to paste it over here so we can see what numbers I'm working off. We kept one of the lines that we don't really need to worry about this, so we're going to get rid of that. Alright, so the two vectors I care about is this vector here and this vector here. So if I want to find the cross product, normally the syntax you could type into your calculator, and there's ways to get here as well, is going to be cross P. This is for the TI Inspire. I believe the Casio functions pretty much the exact same way. We then use these square brackets, and we can insert each of our coordinate points. Now, without doing anything too fancy, if you literally just type in square bracket, I would just do coordinate point 1, comma, point 2, comma, point 3, square bracket, comma between both, square bracket, my second coordinate point of -1, 3, and -3, square bracket. I wind up with just the fast way to find the cross product, calculator buttons, click equals, and you'll find you get an answer if you convert to a column bracket, or column vector, sorry, is 21, 1, and -6. So just using the calculator, type the numbers in, bam, click your enter button, and you get this answer. Once I've got this answer, I now need to find the magnitude of that. Now, I could do all this in one big step, 100% true, but again, you need to know how to find the cross product. You don't always need to know how to find the magnitude of the cross product instantly. Like, it's not a super common exam idea. Cross product comes up in a lot of the papers. Sometimes dot product comes up instead. I would say this one's foundational. The magnitude is pretty easy to find with a calculator. It's not that much quicker anyway, realistically. So, once I've got my cross product, to find my area, we said, okay, well, it's a triangle that is half the area of a parallelogram, and it's going to be the cross product of AB cross AC. And I guess to be formal, I should write that here too, right? I should say, hey, this is what I'm doing. I'm finding the cross product between these two vectors. So if I halve the magnitude, I can find the magnitude very simply by doing a half multiplied by the square root of my real part squared plus my imaginary part squared. I guess I should use brackets for all of these, plus my sorry, I went complex numbers mode with real and imaginary. I mean my I coefficient, J coefficient, K coefficient. Square them all, click enter on the calculator. It's very fast to find the magnitude. So, like, if you don't know how to do it on the calculator, you're not going to lose that much time. We all know how to put square roots in and click the square button. That's you can do on any calculator. So now I wind up with an answer of 10.93 units squared, and that is the answer for question 1. I come across here to question 12. The lifespan of batteries manufactured by a company is assumed to be normally distributed with an unknown mean and standard deviation. Okay. A supervisor at the company randomly selects N batteries and uses the lifespans from this sample to calculate an approximate 95% confidence interval for the population mean of 2,321.4, 2,423.6. Determine the mean lifespan of this sample of batteries. This is really like a methods idea, right? If I want to find the mean of the sample and I'm given a confidence interval, well, the mean is going to be the center, the mean of the sample, I should say, is going to be the center of the confidence interval. So to find the center of my confidence interval, I simply just add my boundaries together and I divide by 2. In other words, my sample mean, which is given by x bar, is equal to, I don't really need brackets, I'm just going to write it out, 2321.4 plus 23.6, all divided by 2, calculator buttons, and where are my calculator buttons? So I can just do this very quickly, and I'm going to get an answer of 2372.5. I don't know why I'm reading out numbers that way. 2,372. I don't know why I was doing that for all the numbers. I actually never read numbers out that way. Don't know what came over me. It just seemed easier in the moment. This is what happens, right, when you're talking a lot. Your brain just does random stuff. That was a random thing my brain did, so apologies. Alright. The standard deviation of the lifespan of batteries in this sample is 125. Determine N. Okay, so this is going to require, like, normally when we're finding N, nice little tip, we're going to need to N solve. Okay? Typically in a tech-free paper, that is. Because whenever we're finding the sample mean, it can be quite an awkward rearrange, okay? We actually have some choices for how we want to go about this. Basically, we don't know we don't know what the number of things in the sample are, but we do now know what the mean is. So I'm going to have my confidence interval is given by 2372.5. And I'm going to put this part in green because I'm going to erase it. I now plus or minus my z-score multiplied by my standard deviation divided by the square root of n. I know my z-score because I know my confidence interval specifically is for 95%. That was given in the question. I should have highlighted more, apologies, but that's given in the question here. So my z-score for a 95% confidence interval is going to be 1.96. There is ways to find that on the calculator, but it's so common in both methods and specialist, it's probably a number we already know. So I've got my 1.96. Now, I also know my standard deviation here is 125. So the only thing I have here to find is n. Notice I included both the plus and the minus. I can pick. I have full choice to pick. I just want to pick one. I know if I add my z-score times my standard deviation divided by the square root of n, I'm going to get the answer for the upper part of my confidence interval, which is 2423.6. If I subtract, I get the answer for the lower bound of my confidence interval, which is 2321.4. Both should give the same answer. I like to add things. I just feel like it's kind of easier to, like, if you have to rearrange. So I'm just going to do the upper bound. It doesn't matter. You should get the same answer for n no matter which way you do it. So if I use my upper bound, I'm basically saying, if I put all of my numbers in, I said I was going to erase it. I've changed my mind. I'm going to leave it there. I've got 22,372.5 plus 1.96, that is my z-score, multiplied by the standard deviation of 125 divided by the square root of n. All of that is going to equal my upper bound, which is 2,423.6. Now, I'll zoom down a little bit so you guys can see that. Now, this is what I have here, right, in terms of my answer, is I have a situation where I can do a bunch of rearranging and solving. It's going to take a ton of time, and it's not worth it. Here, I'm going to n solve, because n is just part of my solution here. I'm not going to waste the time rearranging. I'm simply going to n solve. There's a few different shortcuts you can use to do this. I don't mind how you do it. If you don't know how to n solve, I'm sure you could find videos or information on that. Ask your teachers, all that stuff. I'm just kind of showing what the core skills we should be doing are. So, all I'm going to do is I'm going to n solve for, I type in n solve, I put in brackets, I type in this entire line, I'm going to put a box, I'm going to type in this entire thing here, okay, which is going to be 2,372.5 plus 1.96 multiplied by 125 divided by the square root of n, all equal. Wait, pen work. I need to put myself on the other side. I keep running in. I know, sorry, we're doing another slight delay here. I'm just going to take myself over here. Okay? Because I feel like I'm running... Oh, well, I guess I've run into trouble here too. But I feel like it's easier than me being on the right-hand side. So I've swapped spots. Magic. Alright, so I'm going to say all of that is equal to 2,423.6. Now, we do have to do one last thing. That is comma right in the variable, which is going to be n in this case, right? I could do n solve for any letter. It doesn't have to be the letter n. It just happens to be n in this case. So, n solve or numerical solve, different ways to find it. You type in your equation, equal sign, all of it, comma, you put in your variable, you now slam enter on the calculator. It should be worth pointing out n solve gives you the closest answer to 0 normally. Some calculators have different programming, but normally it's the closest answer to 0. So, if you have multiple solutions, n solve doesn't work so well. In this case, we're only going to have one solution. There's one value for n. That is going to equal 22.98 if I type all that into my calculator. And look, there's debate around rounding up, rounding down. It's people. How can you round up? You can't have 0.98 of a person, all that stuff. I spoke to the QCAA. So the QCAA basically says, just round it. You can, like, it will essentially accept both answers in most cases when you have these, like, weird breaks. Normally, the instructions given on the exam is round to the nearest whole number. So we're just going to do that. We're going to say, therefore, sample size. We're not going to overthink it. Sample size was, or sorry, I shouldn't say is, was 23. Okay? Now, I know people that, like, will go and substitute this value back in and try to see, like, you know, which one's going to give the answer and all that. You can do checks. But like I said, instructions on the website is basically, from the QCAA themselves, is just round to the nearest whole number and you'll be fine. If your teacher has different advice about that or they've heard something different, do what your teacher says. This is just me with conversation I've had. I know it's tied a lot of my students into knots over whether to round up or down with things like this. Like, can you even round up? Does that make sense? We still get the same answer, all of that. In this case, like I said it a few times, nearest whole number, you'll most likely be fine. There is actually some exceptions, but for things like this, you'll most likely be fine. So we go across to question 12. Oh, still question 12, I guess. Okay, we got a part C. So part C, we have a using your results from part B. Explain whether the assumption that the lifespan of batteries is normally distributed is required to support the supervisor's claim. Use results from question 12b to explain whether the assumption that the lifespan of batteries is normally distributed is required to support the supervisor's claim. Well, the rule we say is 30. So if it's above 30, it can be normally distributed. If it's below 30, it can't be. That's like the specialist rule. Methods, I think, might have a slightly different number. I'll revise that if we do the methods paper. But for specialist, no, it's a hard 30. I think methods, there's some slightly different ideas. For specialist, 30 people. Well, we're at 23 if we round up. So we're below the threshold. So therefore, n is less than 30. So it cannot be normally. I don't know what that sound is. Sounds like, yeah, I don't know if you guys can hear that. Something sounds like it's breaking, but we're gonna push on because maths can't, maths doesn't wait for anyone. It cannot be normally distributed is the answer here. Wait, I need to start this again because I've got myself the sound. I'm gonna blame the sound. Oh wait, I literally got the word above me and I nailed it. Okay, cannot be normally distributed. I think that's probably fine. Use result, explain, we did explain, is the assumption required? I guess, this is a weird one. I actually remember solving this and having like some really big conversation with students about if the answer is yes or no, because it can't be normally distributed, but I believe the solution says, therefore you would answer with yes, the assumption's needed, because it can't be distributed, so the supervisor needs to assume it can, even though technically the assumption's incorrect. So this is one where I'm just not going to worry too much. They've changed the wording. This question's been looked at. You're not going to get too much ambiguity about answering with yes or no. The simple thing we need to remember for future exams for 2025 or 2026, whenever you're watching this, is going to be that if n is less than 30, it can't be normally distributed. That is the key takeaway from a question like this. It really should be 1 mark. Okay, so that sounds persistent. I think if I'm talking, you guys can't hear it. I hope that's the case. I'm so confused. I honestly don't know what to do. I don't know if I need to turn this off. Is this going to be really annoying? What the heck just happened? I thought that was coming from my air conditioner, and then it sounded something like there was a whippersnipper out the front. So, okay. Whew, we're back. Alright, question 13. The area under the graph of the function f of x equals 0.2 e to the negative 0.2x for between 1 to 9 is shaded. Cool, we can see that in the picture. Use Simpson's rule with 4 intervals. Love Simpson's rule with 4 intervals to determine an approximation for this area. So this should be a question that shouldn't realistically be too bad. We want to start by, for all our Simpson's rule questions, finding the width, right? So we're going to start by finding w. W is normally equal to b minus a divided by n. I know my upper bound's 9, lower bound's 1. That is going to give me 8 divided by 4 is the number we are looking for here. So it's 8 divided by 4, which gives me a value for w of 2. I did talk a little bit quick for that, but hopefully that all made sense. It's just really part of the formula, plugging numbers in. So if I want to use Simpson's rule, I'm basically saying I want to find the integral, an approximation for the integral between 1 to 9 of my function with respect to x is equal to, and I realize these things take up a lot of space. I'm going to quickly resize this, make it a little bit smaller. I'm just going to grab all of that too and make this part here just a little bit smaller too. So I can bring this function across, and I can try to fit in the whole thing. There's different ways for how we set up our Simpson's rule, okay? I would normally say it's a pretty safe bet to start with some kind of algebraic version of what you were going to do, okay? So that's going to be w divided by 3 for my function at the beginning, right? x0 or x0, plus my last term. I know there's different ways, right? I always just do first plus last. I know people do first plus 4 times your odds, 2 times your evens, plus the last. It's fine, you get the same answer both ways. For whatever reason, for me, I just go first plus last plus 4 times odds plus 2 times evens. Done. It just makes more sense. It's how I remember the rule. It's not on the formula sheet. You need a way to remember it. This is how I do it. If you change it, same answer. So I do first plus last, plus I do 4 times my evens, That's 4 outside of f of x. Well, I guess we got x1 plus f of x3. Sorry, 4 times odds, 2 times evens, right? 4 times odds, 2 times evens, so I got my odds. Then I'm going to do my evens. It's going to be plus 2 times 2 times my evens, which is going to be x2. And, well, there's my other even number is 4. So that's going to be the whole thing. And I'm going to do 3 brackets at the end. The bracket around the x2, the bracket around the whole function, because it's being times by 2, the bracket at the end. So I've got a triple bracket at the end. It's mostly fine, right? You're not going to lose marks if you don't include a triple bracket, most likely, as long as it's right on your calculator. So once we've established everything, we've got our rule, it's algebraic, we can now say, okay, well, I know what these values are. I can just straight up substitute in. I know there's some teachers that teach you how to make the table of values. It's fine if you do that too, right? You just need a way. I know that if you do the algebraic rule and then you put in the correct values in function notation that you would substitute in, it is a slightly faster way to get to the answer. So my W value is 2. We found that out over here. My W value is going to be 2. So this becomes 2/3 outside of, well, x naught, my first term, is my first term. That's going to be 1, plus my last term, that is going to be 9, plus 4 times my odd terms. Well, we got 4 intervals, right? It's got a width of 2. So we're going from 0, we go up to 2. Okay, so we go up to 2. That's going to be my first, I guess. Oh, sorry. We got up by 2, but we go from 1. Apologies. So it's not going to be 3. It's going to be 2, sorry. It's going to be 3. Let me just get my words in order. Okay, so I feel like I need to explain that a little bit better. We're starting here at term 1. My last term's term 9. My W value is 2, so I'm going up by 2s. So my first term is going to be 1 plus 2, that's going to give 3. Then I go up to 5, that's going to be my term in the middle. Then I've got 7, that's going to be my term here on the end, in terms of what values am I substituting in, okay? Just so it kind of makes sense what my numbers are. So we go 3, we're then going from x1 to x3, so going up by 4, I get to f7. Then I'm going to add that to 2 times my even functions, which is going to be f of 5. Again, I got my triple bracket at the end. If I type all that into my calculator, I click equals, I'm going to get 0.65. Oh, I should mention units squared. I should mention that we have to do it with function notation. We do need to, on our calculator, define the function. Okay, I guess that's the calculator trick that I didn't quite mention. We can define our functions a few different ways. We have 2 tricks to how we do it. How I do it is there is a button called define. It looks like that. It's normally next to... Hang on. I've got a red version of a TI here. It's next to the book. If you guys can see. Hang on. This button here. Okay, if I click control, this is the red version, right, but the blue one most of the time. I click that button, I get defined. So I can simply do f of x is defined by, and I can type in this function, 0.2 e to the minus 0.2x. I click enter, and it says done, I believe, if it's done properly, and then you'll find that you've now stored the function as 0.2 e to the negative 0.2x. Once you've stored your function, if you literally type this in exactly as I've written it, and you've stored the function correctly, it automatically does the substitution into the function for you. You get your answer very easily. If that fails, option 2 is create a new page, create a graphs page. Just put in this function as a graph page. It'll say like, f1x like it normally does. You type in your function, 0.2 e to the negative 0.2x. Enter, obviously it'll sketch it for you. It should look similar-ish to this picture here. Once you've got your sketch, you can then go back, and instead of writing f of x, you would have to write f of 1, and you'd have to put little 1s in all the spots here. But again, I just tend not to do it. I use the define key, so it's whatever. As long as you can store your function, you can use the function notation, and everything should go very fast for a relatively easy 4 marks. Okay, well, we have a lot of space for this. Okay, so part B, use a calculus approach to evaluate the reasonableness of your area approximation from question 13a. So a calculus approach is literally just using your calculator to perform a definite integral. Your calculator can do definite integrals when it is in test mode. It can't do like a general integral, but it can do a definite integral. Again, at 0.2 e to the negative 0.2x. That is the function we are differentiating. If you type that in, you use calculus, you differentiate, you get an answer of 0.65, which, what do we know? Wait, I need to go back a page, apologies. Is the same as the answer we got. So I say, therefore, Therefore, the approximation is reasonable. Approximation is reasonable. Okay, a lot of these Simpsons rule questions have this part B added on. We have to determine the reasonableness of the solution. This one is no different. It's been something like this on a number of papers. It might actually not get asked. It's been asked so often, but it was definitely a big theme early on in the specialist exam. Doing Simpsons rule seems pretty important, or really all, you'll get an integration approximation most likely. Just like in every exam, we got question 14 here, right? It's a Leslie matrix. Every single exam either asks you a Leslie or a dominance. They're your two options. Every exam is either a Leslie matrix or a dominance matrix question in it as well. So I would definitely recommend preparing for both, because you just don't know which one you're going to get, right? It's a bit like the driving test. Do you get a 3-point turn or do you get a parallel park? That used to be what it was. So prepare for both. You're going to get one or the other. In question 14, right, you're going to wind up with a Leslie matrix. So this paper, it's a Leslie. It's been pretty split between them. It's been Leslie, Leslie, dominance, Leslie. I forget the exact order, but there's Leslie, I'd say, like, is slightly harder. Depends if it's going to be, I think there was actually a really good dominance matrix question last year, but I could be wrong. It could have been Leslie as well last year. So, either way, prepare for both. The Tasmanian thornbill is a species of bird that has an average lifespan of 3 years. Female thornbills do not reproduce in their first year. Okay. But produce an average of 4. Okay, so it's basically explaining where the numbers come from. We get 4 in their second and third years. So each, I guess it's important to understand the time frame, like each of these iterations, right? So this is basically 0, 1, and hang on. No, wait, it's actually established as being the first year. So it's first year, second year, third year. But it's basically the time frame is going up in years. That's, I guess, the main thing. Each iteration of a Leslie matrix goes 1 year into the future. Okay, this time scale can and has changed. Actually, I think maybe there was a Leslie matrix last year and they had a different time scale. So this one, a lot of the questions have been going up in 1 year increments. Leslie matrices can do it in groups of 3, 4, 5, whatever. So you have to figure out each iteration of a Leslie, how much time has passed. So each time I do, Leslie matrix times my population matrix, I get 1 year of time passing. So I got my Leslie matrix L here, and I've got two values. State the values of X and Y. Okay, I need to read a little bit more. The survival rate of each group is estimated as 25% in their first year and 30% in their second year. So really all we've got is a question that just assesses, do we understand how a Leslie matrix works, right? It's birth rates on top and it's survival rates going down this diagonal here. My first year is going to be 25%, so X is going to equal, if you make our percentage into a decimal, X is going to equal 0.25 or a quarter, and Y is going to be equal to 0.3. So we've got our values, right? And once we have our values, we have our full Leslie matrix. At the start of 2021, did we have a time period before? Okay, no. So at the start of 2021, it's always worth checking because people can make, the only main mistakes people make here is around the time frames. So, at the start of 2021, a study began into the population of Tasmanian thornbills. The study estimated that the initial female population was 510 in their first year, 480 in their second, and 420 in their third. They also found that the ratio of male to female was approximately 1 to 2. Okay, so there's 2 females for every male. Estimate the total population of Tasmanian thornbills at the start of 2025. Okay, so a few things we need to know about Leslie matrices. We only track the female population. The reason why we only track the female population is because only the females reproduce in any species. And the birth rates are what's at the top. So you can't really multiply the 4 birth rate by the male population because the male population is always going to be 0, 0, 0 along the top because males don't give birth. So it's just the females that go into my population matrix. So I need to kind of always do some scaling to get my male population to then find the total. And normally it's simply just 50-50. They made this one a little bit different with 1 to 2. If it's not specified, you normally just double it, basically. You just assume that if you got the female population, it's a 1-to-1 ratio. So if you got 20 females, you got 20 males. That's normally the assumption, unless told otherwise. We are told otherwise in this question. We are told it's not 50-50. It is 1 to 2, so twice the number of females to males. So I want to start by finding my initial population matrix. Okay, we can call that PO or we can call that P. We've got different options. PO seems as good as anything, right? So P0, I suppose I should say. So I want to establish my population. We are starting with 510 year 1, 480 year 2, 420 year 3, and again the scale here is years. Again, really important to note the scale. If it's 1 year, I should say 1 year, right? It's years, it's specifically 1 year per group, 1, 2, 3. So once we've got our population matrix, I want to estimate the total population of thornbills at the start of 2025. Well, each time I multiply by my Leslie matrix, 1 year worth of time has passed. So if I'm starting at 2021 and I times by my Leslie matrix, I'm getting the population at the end of 2021, or another way of wording it, the start of 2022. So in other words, if I do L to the power of 1, okay, I guess I should establish it like this, right? My population, actually, let's just count them out, right? So if I'm going from 2021 to 2025. So I go Leslie matrix power of 1 gets me to the start of 2022, power of 2 gets me to the start of 2023, power of 3 gets me to the start of 2024, power of 4 gets me to the start of 2025, okay? If that made sense. So I'm going to find my population. Where's my pen? Why does sometimes, you know? There we go, I'm back now. My pen is now working. So I've got my population at the end of the 4th year is equal to, essentially, it is going to be my Leslie matrix. I'll just write the whole thing out to remember what our numbers are. But I could call it L, because it's called L up here. And the way I do it in the calculator maybe would be, you know, storing it as a variable, but we can talk about that a little bit after. It is going to be 0.44, and then it's 0.25 and 0.3. So 0.44, 0.25, 0.3, and 0 everywhere else. Okay, so that's my Leslie matrix. I want to, we said power of 1 gets us to the start of 2022, power of 2 gets us to the start of 2023, power of 3 gets us to the start of 2024, and power of 4 gets us to the start of 2025. So I'm taking my Leslie matrix to the power of 4, I'm multiplying by my original population of 510, 480, 420. Now you can store these matrices. It doesn't always make it that much quicker in the exam. You have to write the matrix out the first time anyway. If this is the first time you have to write it out, just write it out, put your little power of 4 there, click enter. As long as you know how to store a matrix or write up a matrix on the calculator, that is really all the calculator skills required. If I click enter, I wind up with a population. I guess I should point out there's some fast-ish ways to quickly sum up the rows. Again, I feel like your teacher will probably have explained that, right? As long as you understand how to use a matrix, the main tech active skill here, putting a matrix in, putting power 4, putting in the bracket. Maybe I'll do a bigger, like, tech active skills video. If people want that, feel free to comment that down below. If you just want to, like, how do I do all these different buttons you're talking about? That could come in a separate video. If I find my total population, I get 3,185 females, okay? Now, I know a few ways to work this out, right? Basically, half of this is going to be the number of males. It's 1 to 2, twice the number of females to the number of males. So I could halve it, then add it back to the original. Or I could just increase the total by 50%. Hopefully that both those options made sense. Halve it, add it back to the original, or just increase my population by 50%, because half of the population, basically half of this number of the population is going to be males. This is harder to explain verbally than I'm hoping. Hopefully it makes more sense than it sounds coming out of my mouth. Basically, I can increase by 50% to find the total population, males and females included. So again, halve it to find the males. This is the females. Halve that number to find the males. Add it back to the females as option 1. Or option 2 is increase by 50%. I'm going to pick option 2. If I increase by 50%, that is like 150 over 100, or 1.5. 3 over 2. Multiplied by 3,185. This should be pretty easy to do on the calculator, right? You get around 4,778, and we should always round to the nearest whole number because we can't get half of a thornbill. So we should always round down, actually, specifically always round down to the nearest whole number when it comes to population sizes in this context, not the stats calling context, the context of Leslie matrices doing populations. So honestly, not a bad question. Just like a lot of like, you have to know how Leslie matrices work. You need to know like pretty well how both Leslie and dominance work for the type of questions you could wind up facing. All right, we're at question 15. I'm gonna have a sip of some water. Don't know why I announced that. Staying hydrated is important, right? Bring a bottle into the exam. That's a good tip. So, question 15. Water is poured into a cone-shaped cup at a rate of 2 centimeters cubed per second. The cup has a height of 12 centimeters and a radius of 6 centimeters as shown. As the cup fills, the ratio of the height of the water h to the surface radius of the water remains constant. Okay. I feel like I read that out a little bit sloppily, but that's okay. Given that the height equals 2 times the radius, and I guess that ratio is constant, so it's always, the height's always going to be equal to double the radius. Determine a function for the volume of the water in the cup V in terms of h. Express your answer in simplified form. Look, this related rates cone type question, I think there's literally one in the Cambridge textbook, if you guys did this lesson, so it should be one that's familiar, right? This definitely, well, I don't know why I got that option up, but this is definitely, like, firmly in the simple, familiar category, okay? It's a common question archetype. Most likely won't necessarily be asked again, but the skills for these types of questions tend not to change all that much. So, it's important to identify, really, like, what do all these little bits mean? These related rates questions can be easy if you correctly diagnose the question, basically. Okay, I'm going to go put the fan on. 1 second. And I'm back. That's like magic, isn't it? Okay, so what I mean by that is water's poured into a cone-shaped cup at a rate of 2 centimeters cubed per second. So, oh, okay, cool. You guys can't hear the fan at all. Just wanted to make sure that the volume wasn't coming through. Sorry. So, I want to start by identifying what is this actual, like, this is a rate of change, right? What is this rate of change giving? Well, I know I got centimeters cubed, so it's going to be a change in volume, and my variable's time. So identify that this is going to be a change in volume with respect to time, dv dt, and I actually have a hard value for dv dt equaling 2. For all of our related rates questions, we need to know basically one of the rates, and then figure out the relation between them, but we need to know one of the answers. Okay, we're told some stuff about the max height, but really we're looking at the shaded bit where the water's filled in. So I guess I've identified the first thing about dv dt equaling 2. Like, that matters. I even put equals 2 there just to make it super clear what that means. However, part A is like a little bit separate to that, right? I'm basically told the ratio between the height, like h equals 2 times r, and that ratio is constant throughout the entire thing. So I can find my volume, right? My volume of a cone is equal to 1/3 pi r squared. I nearly did cube for a second there. It's pi r squared h. So 1/3 pi r squared h. Once I've got my volume for my cube, I know from the question, this part here, maybe I should highlight instead of circling, this part here is going to mean that if I just simply rearrange height equals 2 times r, that means that r equals half the height, or height divided by 2. I can now substitute this into my equation. Again, when we're doing related rates questions, we've got two things we don't know. We don't know the radius, we don't know the height. It's essentially impossible. So we need to try to, for all of these, make some kind of substitution to remove one of the variables, or some of the questions that are slightly easier. This could be graded as a CF. What question number are we up to? 15? Normally it's 16, 17 a CF, 18, 19 CU. It's 8 marks, so this, I guess it could be simple for me, right? Like I did say this was like literally a textbook example, but it's a little harder to do this kind of substitution, but I guess they lead us with it being a part A. All of this is to say that two unknowns makes questions, like, for the most part, like, semi-impossible. So we get rid of one of our unknowns, so you just make h the one thing I don't know, so I can actually do some kind of calculus on it later on, most likely. That's going to equal, let me get my color right, that is going to be equal to 1/3 pi multiplied by h over 2 squared multiplied by h. I can simplify that. I'm going to simplify this kind of in one step because I've run out of room a little bit. If I square top and bottom, I get h squared over 2 squared, which becomes h squared over 4, if you're following. So I have basically a quarter times a third at the front, multiply across the bottom, I have 3 times 4. I'm going to wind up with an answer for the volume being equal to pi h squared times h gives h cubed, all divided by 12, and that's just a little bit more simplified, a simplified version of what my volume expression could look like, which might, hopefully, make it slightly easier when we almost always have to do some kind of calculus, right? Because we're going to get one of our rates. If we can't see it and we haven't practiced these questions enough, one of the rates is given, The other rate we normally find using some math facts about the question. We create an expression. They kind of hinted and led us towards what the expression should be. They don't have to give us part A, by the way. They can kind of jump straight to like show the rate at which the height is increasing by is given by. Like some kind of question like this, we have to combine the rates. To find my other rate in the related rates part, I normally create an expression and then differentiate. Okay, and we'll talk about that because I'm sure it's going to come up in part B. So use the results from question 15a, the expression we just found, to show that the rate at which the height of water in the cup is increasing with respect to time is given by 8 divided by pi h squared. So, I guess we should clarify what this is actually finding here. Show that the rate at which the height of water in the cup is increasing. Well, it's increasing with respect to time. Oh, it literally says with respect to time. So there we go. So therefore, what I'm actually trying to find is the change in height with respect to time. And I'm giving it an answer, which means if it's a show, likely there's a part C. Yeah, likely there's a part C, and they've given us the answer in part B, so we can solve part C anyway. So I've got what I'm trying to find is the change in height with respect to time. I know the change in volume with respect to time, and I know an equation in terms of volume as well. So I guess I have to try to create my related rate, okay? I know that the thing that I'm trying to find is the h over the t, but I'm given, well, that's a highlighter. I'm given change in volume with respect to time, that was given to me in the question, is going to be equal to the change in volume with respect to the change in height, multiplied by the change in height with respect to the change in time. And again, I get some cancelling. You can see this all equals the v to t. The thing I'm trying to find is this bit here on the end. And I actually know, well, I know the v to t, that's going to be 2. That's from above. And I can differentiate my volume with respect to h, now that everything's in terms of h. I can differentiate my volume with respect to h to get an expression for dv to h. Okay, I'm going to start with that there. I'm going to find dv dh. If I find dv dh, that's going to be equal to, I just bring the power out the front and subtract 1 off the power. So I bring h out, I get 3 over 12. That is going to give a quarter. So what I wind up with is pi h squared over 4. You can do that slower if you need more time, right? This is just a somewhat basic derivative. So I get dv to h. I now know dv to t is 2. I can substitute in. I get 2 is equal to pi h squared over 4 multiplied by dh over to t. I now just rearrange to make dh to t the subject. That's what I'm trying to achieve all along, really. I can multiply by the reciprocal of this part here. So basically, I can multiply by... Let me make this... I'll drag this out a little bit so I can put it in here in orange. I'm going to multiply this by 4 over pi h squared. That is going to cancel everything out for me. It's gone. I'm now just left with the h to t on that right-hand side. But to balance, do the same thing here. I multiply by 4 over pi h squared. And you can see there's my answer, right? I'm going to wind up with multiplying along my fractions. I get... Oh, I actually shouldn't write outside the box. It actually won't get scanned. I'm going to do it right now because I can. But in the actual exam, don't write outside the box. Your answers will not be scanned. They will not go to the QCAA. They will not count. You will just... It'd be like you didn't submit an answer. So the h to t is equal to... 4 times 2 gives me 8 over pi h squared, and I've got my 3 marks for part B. Coming across to part C, determine the... And again, there actually wasn't that much tech involved in that at all, to be honest. Like, this has been tech-free so far, so we probably will get some kind of tech-active component for part C. Otherwise, this could have just been in the tech-free paper. I will say, the main application in the tech-active exam is to use NSolve. That is probably the most important thing to know going into the tech-active paper, is being able to use NSolve to generate solutions. If you can't NSolve answers, you're going to take so much time, you will not finish the exam. So, determine the rate at which the height of water in the cup is increasing with respect to time when the volume of the cup reaches half the total capacity of the cup. Okay, so... Interesting. Okay, so we need to find the total capacity. The total capacity is going to be the volume of the cone. I know the max height's 12, and the radius is going to be 6. It stays that kind of 2. It makes sense, right? Radius is 6. Double it, I get my height, I get 12. So what I wind up with is volume. My whole volume, my entire volume, my volume of my cone is equal to 1/3 pi. It's not r squared now. We know r is going to be 6 squared multiplied by 12 squared. And in case that wasn't clear why I couldn't do that before, is we're trying to find the gray area. That's why we had to keep these things as variables when we did it this time with this equation over here. But now that I know it's the full volume of the cone, I don't need to worry about the variables. They have values of 6 and 12 when it's at its max. So I'm going to do this to find my volume. I type this into my calculator, I click equals, and I get my answer. Okay, once I've done that, I simply just divide my answer by 2. There's a few different ways I could write this out. I'm just going to do it like this. Brackets, divide by 2, I get half the capacity. So I just type this into my calculator, I'll wind up with an answer of 226.195 centimeters cubed. That is half the total capacity of the cone. Once I've got half the total capacity of the cone, determine the rate at which the height of water is increasing with respect to time. So I can now use this equation here where I say, therefore, okay, the volume, I guess at half my capacity is going to become pi h cubed over 12. The reason why I'm using this pi h cubed over 12 expression over here is because, again, if I have two unknowns, it's very difficult, but I have an expression with just one variable. I know my answer for what that volume is going to be. Maybe I can get rid of this equal sign here. Now, the answer for what my volume is going to be is 226.195. I can now solve for h, okay? So I'm going to use nsolve, save myself some time, don't have to rearrange. I'm going to say that if I nsolve for something like this, that is going to be pi h cubed over 12 equal to 226.195, comma, my variable in this case is h, close bracket, smack equals on the calculator, and I get h is equal to, if I type all of that in, I get 9.52 centimeters. Okay, that's my value for h. So now I found h. I simply can just substitute my value for h into my rate of change, which I found in part B, which is 8 over pi h squared, or if I didn't get part B right, I could use the answer that we're meant to show here for the 8 over pi h squared. I know h is about 9.52, but I would always, for all the tech active papers, use the exact answer where you can. You can literally type this in, actually. You could literally do it like this. You could write it as, to go really crazy with making it exact, I could say my change in height with respect to time is equal to 8 divided by pi multiplied by nsolve, just to show how much you do on the calculator, nsolve pi h cubed over 12 equals 226.195 comma h squared. You can literally write it like that and have it the most exact thing you could possibly imagine. You can argue it's overkill, just showing a way you can. Obviously, on some of the calculators, you can up arrow, enter to grab your entire line. My point is, I would be that specific. I'd make my answer as accurate as possible. So it's an option to do it that way. Obviously, it is slightly overkill, like I said, but you would get an answer approximately of 0.3 centimeters per second to the -1 for the rate of change of height with respect to time. Okay. Did a lot of talking for that. Let's jump into question 16. Question 16 is matrix algebra. A matrix algebra question. This is much more in the category of rare, I would say. I guess when I think about it, there's probably one of these every 2 to 3 years, is sort of how it seems to be aligned. But it's a good question, to be honest. I kind of like these matrix algebra questions. I'm given the matrix A. We need to use our calculator pretty well here. Okay, again, if we write a matrix in, I can find a to the power of 4. That's part of the first bit of the given. So given a to the power of 4 equals p a cubed plus q a squared plus r times a plus 3 times my identity matrix. I guess it's relevant. I guess it is relevant, actually. I guess it is relevant. But we have to know that I is my identity matrix, which is 1, 0, 0, 0, 1, 0, 0, 0, 1. Ones on the leading diagonal. So if I do that, I need to use my calculator. This is 100% a question where I'd use the store feature. So there's a few ways to do this. You could say, okay, A, we use the same define button we used when we looked at defining a function. I'm going to define A as being this matrix here. It's the way I do it personally. It is a good option. Okay? We define it. We smack enter. I believe it says done. Pretty sure it says done. And then you can always test, right? You click the A letter on your keyboard, you click enter, or your keypad, you click enter. It should come up with this exact matrix. So once we've stored A, I can now literally just type in basically what I've got here, okay? I need to find A to the power of 4, A cubed, A squared. I know A, it's given the question, I know I. So it's really just actually these first three. If I do that, I put in A to the power of 4, I wind up with an answer of, I'm going to make that bracket a little bit better. Actually, I can use this. This will make it perfect, right? Well, we tried. It's better than I wrote before. I get 177, 176, 144. I get 144, 145, 120. I get 176, 176, 145. That is the answer for A to the power of 4. Okay, so I set A, then I literally type in A, power of 4, enter, I get this answer. I then do, that's P outside of A to the power of 3. A to the power of 3 on the calculator is given by 37, 38, 32, 32, 31, 25, 38, 38, 31. That's the P part. I'm running out of space very quickly. Plus Q outside of, now it's A squared. That is 9, 8, 6, 6, 7, 6, 8, 8, 7. And I now just do R. Well, maybe I should say, whatever. I'm just going to keep writing like this. R is just A as it normally is. That is 1, 2, 2, 2, 1, 1, 2, 2, 1. And I should make my R look a little bit neater because that looked a bit messy. Let me fix that. Ta-da! And I'm going to add in my identity matrix, which is going to be 3 outside of I. I'm going to put that in straight away. I know I is 1's all on my leading diagonal. If I scale my identity matrix by 3, I get 3's on my leading diagonal. Okay? So, voila. I've got this situation here where I have an expression, I have all my matrices. This is very heavy tech active. Again, if you don't define A and you have to write the matrix out every single time, it is going to be very painful. So having some way to define works. Your other option is you write your matrix out. I'm just going to ignore that. There's the store button, okay? The store button is above the variables button there. You see it says STO. Control variable button, you could store, you give this arrow here, you type the letter A in, that will also store it for you. Most calculators won't store it as a capital letter, it'll store it as a lowercase letter, but that's fine, okay? So there's your two options on how to store a matrix, but you do need to store this one, like it made that all very fast. So, essentially, what I wind up with is I have 3 unknowns. 3 unknowns should trigger a thought, okay? If it doesn't, this is the thought it should trigger. 3 variables. I need 3 equations. 2 variables, I need 2 equations. 4 variables, I would need 4, but very rare to see that, right? 3 variables, 3 equations. I need to generate 3 equations, and it's simultaneous. So how do I generate my 3 equations? Well, I actually have a lot of information here, okay? I can simply identify, right? Like, I know the, what's the word I'm looking for? Equivalence. Like the equivalence lesson on matrices. So I know that 177 is going to be equal to, essentially it's the top corner of every single one of these added together. Okay? I do need to bear in mind, I need to multiply P into this matrix. Technically it's 37P, 38P, 33P, 32P, 31P, 25P. Like, I can put P next to all these letters. I can put Q next to all these letters. I'm not going to do that because it's very messy. But what that is all to say is if I just look at my first row, I'm saying that 177 is equal to 37P plus 9Q. Okay, sorry, the writing's very messy. I'm going to zoom in a little bit. Plus 9Q. We're just doing the top right-hand corner of each of these matrices. Plus 1R, I can just write that as R, plus 3. Okay? I need 3 equations. Luckily, I've got 3 numbers on my top row. How convenient. So now, I do the same idea, and I'm going to say that, okay, well, 176 is going to equal the second number all the way along, again, multiplying those values in. And I'm going to do the same idea here for part 3. And I'm going to get my 3 equations this way. So I'm going to go ahead and do that. I'm going to actually grab all of this and make it a bit... Wait, do I have another page? Oh, I do. Okay, let's just generate my 3 equations, then I'll copy and paste them to the other side, and we'll get into actually doing the solution stuff for how we could do a system of equations, 3 variables, all that stuff in our calculators easily as well. Again, this is very, very heavy tech active. So my second number was 176, and it's 144. So we got 176 equal to, it is going to be 38p for the matrix above. I'm just zooming in so I can write a little bit neater, plus 8 lots of Q, plus 2 lots of R, and then I guess I got zeros for the rest, right? But I could write plus 0 if I wanted to, okay? Again, 38,820, and then I've got 144. These are my blue numbers now. 144 is equal to 32,620. So that is 32p plus 6q plus, it is 2 again, plus 2, 2r plus 0. So I've generated 3 equations here, okay? 3 equations, 3 unknowns. I can now make a coefficient matrix. To make my coefficient matrix, though, I need to get rid of all of these numbers here on the end. They all need to go. The zeros are already gone, okay? So I can just essentially erase these because I don't need them. The 3 just needs to be subtracted from each side to create sort of this new matrix at the front. If I subtract 3, then technically I get 174 equal to the rest of it here. But I wanted just to show where all the numbers came from so it wasn't too confusing, okay? I get this. I can now translate all of this to a coefficient matrix. I'm going to copy that. I'm going to bring it across here. So we do the coefficient matrix part of all of this. Paste. What? Did that not copy properly? Copy. Copied. Nice. Paste. Nice. Okay. So if I do a coefficient matrix, I wind up with 37, 9, 1, 38, 8, 2, 32, 6, 2. Technically, I've got my variables P, Q, R, all equal to my answers 174, 176, 144. So I can now find PQR. I can do some matrix rearranging, right? I can find the inverse of each side. So I basically take this whole thing. I'm just going to write it out, and hopefully this will make sense, right? I'm going to get that PQR is equal to the inverse of this matrix here. Inverse of this matrix here. I'm just going to get rid of that because I feel like that makes it look messier, which is simply just on the calculator. All of this is tech active. 37, 9, 1, 38, 8, 2, 32, 6, 2, all to the power of -1, multiplied by 174, 176, and 144. If I do that, I get an answer. For P, Q, and R, I get an answer of 2, 10, and 10. My god, I really am struggling to draw brackets today. Apologies everyone for being so messy. So therefore, P equals 2, Q equals 10, R equals 10. Okay, they are my 3 answers. Honestly, that one was huge and so much calculator work required. Like a crazy amount of calculator work required. Okay, so I guess that was CF, right? This is probably the final CF. And then we should have 2 CUs. 6 marks, 7 marks, so it's 13 marks of CU. And then we have here, we've got 7 and 6. So yeah, 13 marks CF, 13 marks CU. That balances at about the 20% ratio on both papers. So let's just do a projectile motion question. I love projectile motion questions. I feel like it's I mean, I said let's do it. I was tempted to take a quick break, come back and finish off the video, but let's just do this one. Okay, question 17. An object with a mass of 2 kilograms is released from rest atop a 1 meter long frictionless plane. Okay, so we can ignore friction, that's pretty good. 30 degrees to the horizontal. A force of p newtons is acting parallel to the plane, opposes the motion of the object as it travels down the plane. So it's kind of pushing the object back up. When the object is x meters from the top of the plane, its velocity is v. Okay, so we get 2 variables. This is meant to be CF though, right? So, okay. Given the magnitude of p equals 4 over the square root of 4 minus x squared. That looks a little bit like a trig function. Determine x equals v equals 2. Determine x when my velocity equals 2. Oh, okay, we're given an expression for the magnitude of my force opposing. So I actually know that the magnitude of the force P is 4 over the square root of 4 minus x squared. That's actually really important, okay? So, let's draw a picture. For these projectile motion questions, drawing a picture is really good. Just helps you make sure you understand all the information. I've got my plane. Okay, hang on. Well, it's not the straightest. Okay, let me try to fix it. Here we go. Let's see if I can fix this. Make this a little bit more. That's better. Okay, I've got my plane. If you don't have a ruler, it's actually fine, right? It doesn't need to be perfect. I've got an object here. I know it weighs 2 kilograms, so I have a force going down this way of 2g, and I have an angle inside here of 30 degrees. I also have a force going back up against it. I'm going to use a different color. We're going to choose pink because why would we choose any other color? That's going to be P is pushing back up this way. Okay, that's pretty much the diagram I have that I need to consider. Oh, I guess I should consider the length. Is it the length to the point? An object is released from rest at the top. Oh, okay, so even though I've got a ramp above it, it's technically already at the top, and this whole distance here, I need a different color. Let's use purple. This whole distance here is going to be 1 meter long. I'm going to redraw this. I find drawing the diagrams on the planes, if you like to use those, go for it. I just find with the harder questions, it's easier sometimes to do a, I think there's a word for it. I was going to say a plane shift. I feel like that's the wrong term, but whatever. We're basically going to make the plane the horizontal. We're going to tilt the whole, we're basically going to tilt our heads like this. Wait, it's mirrored. Like that way, to make it the plane horizontal. So what I mean by that is I'm going to redraw all of this on a Cartesian plane. If I redraw all of this on a Cartesian plane, again, there's many strategies for projectile motion. If your teacher has taught you a different way, try that way, see if it works. If it doesn't, welcome to my way. So if I tilt the whole plane, I'm tilting the whole plane. Wait, we're mirrored. Let me get it right. So tilting the whole plane. There we go. We're tilting it that way. We're basically taking the plane on that angle, and we're straightening it out. If we do that, if we tilt our heads to, sorry, wrong direction. Everything's mirrored here in the camera, apologies. If we tilt our head this way, then that means my force of gravity, this 2g force, is actually coming out. I'm gonna do it in orange. I know I did it in blue here, apologies. But the force is coming out this way if I make the plane the horizontal. Okay? So I've got my force kicking out this way. And I know the force here is going to be, I'll get off the draw mode, that is going to be 2g. Yeah, I guess I'm going to include the units, but we understand it's 2 times acceleration due to gravity. I just need to figure out what angle my force makes with the horizontal. We always care very much about this angle here. Okay? So, I know my angle in here is 30 degrees. This is the hardest bit, and it's actually not that difficult, but the bit that I'm going to say causes the most confusion when I talk about making the plane the horizontal, is if this is 30 degrees, what I essentially wind up with is, I'm just going to grab this 1M part, pull it across here, just so I can make this picture look a little bit neater. What I wind up with here is a Z angle. Okay, so I wind up with 30 degrees there. I also get 30 degrees here. You can see these two lines here are parallel. So I have a Z angle. That means that the angle from the plane to my actual force, I'm going to zoom in so you make this really clear. What I mean by that is my angle here, well, the whole thing has to be 90 degrees. If that little part is 30, this angle to the plane has to be 60 degrees, which means this angle here that I have in purple is going to be 60 degrees. If you can wrap your head around that, then I think converting the plane is actually a simple-ish way to do it. Okay? Because the reason why it's nice is I can now just kind of look at things in the I direction, right? We're looking at forces acting along a plane. If I make the plane the horizontal, I make it the I component. I now have an I component opposing the force, which is going in this direction here. It's going out this way. Okay? So if it's going out that way, I know the magnitude of that force is going to be 4 over the square root of 4 minus x squared. That is the magnitude of the force opposing the motion of the particle, object, whatever it is, going down the plane. So I've established pretty much what the heck is going on. I've got all the things I need. Everything is in terms of the direction of the plane, so all I really worry about is the forces in the I direction, which means I'm going to resolve the I component of all of my forces, okay? So if I resolve just the I component of my forces, if I find the sum of forces specifically, the sum of forces in the I direction, I get, let's start with the positive direction, right? That's going to be my 2G. It's in quadrant 4. And you can see the direction it's moving is positive in the I direction. So I know if I break things up in terms of the plane, the other nice thing is I keep it very consistent. R cosine theta is going to be my I component. R sine theta is going to be my J component. So if I just consider my I component, okay, that's going to be the I component of R cosine theta. Well, I know R, the magnitude of my force. I'm just going to leave it as being 2G. I could make it 2 times 9.8. I just think it's easy to keep it as 2G for now. So this means 2G cosine theta, and in this case, right, it's 60 degrees to the horizontal. It is positive because it's in quadrant 4, so I just keep it as cosine 60, okay? I close the bracket off on the end, and I'm going to subtract, because it's going in the opposite direction. You can see it's negative in the I direction. I'm simply going to subtract 4 over the square root of 4 minus x squared, okay? That is going to be the sum of forces in the I direction. Once I've established that, I can now kind of look at the other parts of what I'm considering in the question in terms of velocity and position. I'm going to need to look at F equals ma. So I know that the sum of forces in the I direction is equal to the mass times the acceleration. I know my mass is 2. I don't know my acceleration. That's just going to stay as a. But I know the sum of all of my forces is 2g cosine. I guess I can actually substitute that in. Cosine 60 is 1/2. So I'm basically just going to get g, because it's 2 times a half. I get g minus 4 over the square root of 4 minus x squared if I kind of simplify up everything that I'm doing. Okay? I can now divide both sides by 2 to get a, and I get a, my acceleration is equal to, well, 9.8 divided by 2 is going to give 4.9. It seems like as good a time as any to take it out. Minus, if I divide everything by 2, I just get 2 over the square root of 4 minus x squared. Okay, so I'm dividing everything on the left-hand side by 2. You can go a little slower. 4 divided by 2 gives 2. That's where this number up here comes from. But hopefully we're following how I get to this expression here. Once I'm here, I can now start to consider an expression for my acceleration and think a little bit about my expression for acceleration. Nowhere in my question does it mention acceleration. It does not seem to care at all about a. What we do care about is velocity v, okay? Is there a way I can make acceleration in terms of v? The answer is yes. I can say, and this is on the formula sheet too, I can say that, okay, well, my acceleration, a, I'll put this in pink so we know the rule, is equal to my velocity multiplied by dv dx. And again, I've got my velocity in terms of x, in terms of position, and these are the two variables I care about based on the question. I care about my velocity v, and I care about it in relation to x, okay, my position. So I've got v and x now on the right hand side. That seems like a very promising start. I've got velocity in terms of position, in terms of x, basically. So I can now basically make this substitution. I can get rid of my a, I can add in v dv dx is equal to 4.9 minus 2 over the square root of 4 minus x squared. And I've got something that now is starting to get a little bit more exciting, because I'm essentially at the point where I can now start to do some calculus. I can integrate, well, I guess I should get my dx with my x's, right? Like normal rules apply. Get my dx with my x's. I can multiply both sides by dx, and I'm going to wind up with v dv equal to 4.9. I can use brackets if I want to really highlight this point. Minus x squared dx. And it's great. I've got a dx, I've got an x. Awesome. And I did mention before, that looks like an inverse trig function. It's going to be, right? It's even better now with the 2 on top. It really looks like a good inverse trig function. So I'm going to wind up with, I guess the 2 actually doesn't make a difference, right? Because you take the 4, whatever. I can make it 1 easily. We'll cross that bridge in just a second. The point is, I get my dx's with my x's, my v's with my dv's, and I can now integrate both sides of my equation. And I've balanced everything. The maths is working. Life's great. Okay? So if I go about actually doing these integrals, if I integrate velocity with respect to v, raise the power by 1, divide by the new power, I wind up with, if I turn the page here, I wind up with a half v squared or v squared over 2. You can write it however you like. The preferred format, for whatever reason, is a half v squared. But v squared over 2, it's the same thing. You won't lose marks. That is equal to the integral, let's scroll down, of the right-hand side. So I don't really need the brackets in because I'm integrating both parts. I just put the brackets there to show that everything is multiplied by dv. I'm just going to get rid of the brackets so we can do our integration a little bit easier. Sorry about missing a little gap here. Let's fix that back up. If I integrate 4.9 with respect to x, I just get 4.9x. So this is going to be equal to 4.9x. Come back across, and it's minus 2 over the square root of 4 minus x squared. Now this is going to be, it's in the form, it's I guess I have some options right with the negative out the front. Like I technically maybe could do something with like a cosine and make it plus or something like that. I'm just not going to worry about any of that stuff, right? I'm just going to simply look at this part of my function. It's 2 over the square root of 4 minus x squared. I'm going to make it minus sine, 2 sine, I guess I've got the 2 on top, it needs to be a 1 on top, right? It's being minus 2 sine to the minus 1 of, and again, if we sort of remember our rule, it is 1 over the square root of a squared minus x squared. So if I square root the 4, I get the value of 2, so this become 1 over x over, or sorry, sine to the minus 1, brackets of x over 2, or x over a is as sort of the formula sheet indicates. So I've got this expression now. I should have my plus c. I've got my integral. I've now got things with v squareds. I've got it in terms of x, which is all looking really good. I need to find my c value. So I need to look, is there any initial conditions I could use? Is there initial conditions I can use? An object with a oh, it's from rest. Okay, there we go. So it's at rest at the top. So I know it's at rest means my velocity equals 0 when my position equals 0, where x, so it's at the top, right? Rest, sorry, at the top. So it's given by position. We're going to say the top of the thing is like at the starting point. So we say x equals 0. So if I substitute in v equals 0, x equals 0 into my equation, well, I get a half times 0 squared, that's going to become 0, equal to 4.9 times 0, which becomes 0, minus 2 sine to the minus 1 of 0 plus c. Well, I know sine of 0 equals 0. So I'm going to wind up with a value of c equals 0, which is great. I don't need to consider it, and I therefore get this expression here, where it's a half v squared equals 4.9x minus 2 sine to the minus 1 of x divided by 2. Once I get to here, I can now substitute in v equals 2. That was part of the question, right? Figure out the position. When the object is x meters from the top of the plane, its velocity is v. Hang on. Oh, wait, no, sorry, here it is. Here's the bit I was looking for. Determine x when my velocity equals 2. Okay, so if I determine x when my velocity equals 2, I'm simply just putting 2 in place of my velocity, and I wind up with a half 2 squared. I can cut to the chase here a little bit, right? 2 squared is 4. I get 4 divided by 2. I'm just going to wind up with 2. So we get 2 is equal to 4.9x minus 2 sine to the minus 1 x over 2. And once I'm here, I now have x in 2 different locations. That can make it very awkward to solve. Like, actually, almost impossible for us to solve just by using brute force algebraic techniques. But luckily, I said the most important skill is how to end solve problems. I can now just end solve. I've got my expression, boom, I pull the trigger, I get my calculator out, I end solve, I get x is equal to n solve of, again, it's 2 equals 4.9x minus 2 sine to the minus 1 of x over 2. Over 2. There we go. There's my pen working. And again, my variable is going to be x. So I type that in. I simply get x equals 0.51. And I should just quickly consider, make sure my units are correct. It's 1 meter long, right? So it's going to be 0.51 meters, which is about halfway down the ramp. But they didn't really care too much for the context. They just asked for essentially what the position of the object is. Okay, question 18. Consider the polynomial p of z equals z cubed plus az squared plus bz plus c, where a, b, c are real numbers and z's a complex number. Two of the roots of my polynomial p of z are also roots of this, polynomial quartic. This quartic complex number, z to the power of 4 plus z cubed plus z squared plus z plus 1. The remaining root of p of z is z equals 2. Okay, so I've got 3 roots, because it's power of 3. One of the 3 roots is z equals 2, so we could write that as kind of being z minus 2, if we put that in brackets. And the other 2 roots I need to form my cubic come from this particular quartic here. So 2 of the roots of the quartic, I guess that means I can have 2 different pairs of solutions. It says here determine a possible expression, meaning there must be 2 answers accepted here, right? Because I'm going to get 4 roots for my quartic. I can essentially pick a pair of 2 from the quartic. We'll talk about why we're going to have pairs of solutions instead of just 4 sort of individual pieces. We're also told that z to the power of 5 minus 1 has roots of z minus 1 and the same quartic. So, okay, this is a pretty interesting question. We're trying to factorize a cubic. To factorize the cubic, we're given a quartic. To factorize the quartic, we're given a z to the power of 5 function. So this basically becomes a sort of like, what's it called? Like roots of complex numbers, roots to the power of n, like an nth root type concept, like a reverse de Moivre's theorem type of idea, where I'm basically saying that I want to say, okay, I've got z to the power of 5, specifically z to the power of 5 minus 1 is equal to 0, right? There's kind of 2 ways we can interpret this. I want to essentially just factorize, wait, let me fix this. I want to factorize z to the power of 5 essentially equal to 1, right? If I rearrange z to the power of 5 minus 1 equals 0, if I rearrange that, I get z to the power of 5 equal to 1. If I can factorize my z to the power of 5 using a reverse de Moivre's idea, I can basically get 5 roots. One of those roots should be 1, because I know z minus 1 is one of the roots. And the other 4 roots will be the 4 solutions from this specific quartic, which I can then use to factorize my cubic. So I actually will say, like, this is a perfect example of a complex unfamiliar question that is a lot to unpack, but if you identify where to start, actually does unravel quite nicely. So I'm going to go ahead and use my reverse de Moivre's. I know there's different ways to lay this out. Like all things in specialist maths, the harder maths gets, the more options you basically have for how you want to go about solving. The way I normally do it is I simply just, and this step's pretty much the same for all of them, I let the right-hand side, the 1, I write that in polar form. So different ways to write polar form. For most of Queensland, we use the cis notation. So that's going to be 1 cis. I know my angle, because it's just 1 on the real part, right? I consider myself an Argand diagram. It's going to be 1 here, which means it's actually on my my real axis, meaning that I have an angle of 0. So we have an angle of 0 here. I don't really need to write the 1 either, actually. It's just kind of showing that's the magnitude. So r cis theta, that is my complex number written in polar form. Once I've done that, I can sort of reverse my power of 5. So I'm kind of reversing my de Moivre's theorem, and I get a solution for z is equal to, I'm going to take the 5th root of 1, that just gives 1. So that part's going to stay the same. So it's going to be cis outside of, again, different ways to write this part out. I normally do 1 over n, which is going to become 1 over 5, outside of theta, which in this case is 0, plus 2 pi k. So once we've got this expression here, I can now substitute in k equals 0, 1, 2, 3, and 4 to get my 5 solutions. Once I got my 5 solutions, again, one of them should be z equals 1. The other 4 will be the roots of my quartic. So I'm going to start with k equals 0, because that's just the easiest place to start. I start with k equals 0. I wind up with z is equal to just cis 0. And that's all there is to it, right? I put 0 in place of k, my 2 pi disappears, I got 1/5 times 0, it's just going to become 0. So it's cis 0, and I know cis 0, we literally just saw it above, it's going to be equal to 1. If I convert that into real and imaginary components, I basically get cosine 0 plus sine 0 I, sine 0 is 0, I part disappears, cosine 0 is 1. So I wind up with the solution of 1. That is the solution I was looking for here, meaning that when I do k equals 1, 2, 3, and 4, I get the other 4 solutions for my quartic. So if I do k equals 1, I'm going to wind up with z is equal to, or one of the solutions of z I could say, is equal to cis of, I'm going to do this a little bit in my head, it's not too hard, right? I'm basically putting 1 in place of k. So I get 1/5 times 2 pi, I get 2 pi on 5. I'm now going to do when k equals 2. And I'm going to wind up with z is equal to cis of, now it's going to be 4 pi, so it's going to be 4, well, I never wrote 45 then, it's going to be 4 pi on 5. Again, we want to keep everything in principal argument form, so that still looks really good. I'm now going to do when k equals 3. When k equals 3, I get z is equal to, I now have 6 pi on 5. Well, 6 pi on 5 is now falling outside of between negative pi to pi. So, just in case we have forgotten, for any angle or the argument of a complex number, I want to express it between minus pi to pi. Okay, so that means that, and specifically if it's negative pi, it just becomes positive pi, right? You can write this with inequalities, but that's the gist. From minus pi to pi, 6 pi on 5 is bigger than pi, so I want to write that as a negative angle. It's specifically going to be minus, it's going to be cis of minus 4 pi on 5. And for the final solution, when I do k is equal to 4, I guess I could stop, right? I'm going to talk about pairs, but I may as well do all 5. I get z is equal to cis of, well, I'm timesing by 4. It's going to be 8 pi on 5. Again, I can make this negative, and I get negative 2 pi on 5 here. Now, you might be wondering, why did I take out k equals 0 into a, like, I basically broke up the polar form into my real and imaginary parts? I didn't do that for the rest. The reason why I didn't do it for the rest is because I want to identify a pair of solutions. We hopefully can remember that we have conjugate root theorem. So if I have a complex number as a solution, the conjugate must also be the solution, which means even though I've got 4 answers, I basically have 2 conjugate pairs. I've got my 2 pairs here. This is the cis 2 pi on 5 and the cis of negative 2 pi on 5. One's the conjugate of the other. I also have my other conjugate pair, that is going to be cis 4 pi on 5 and cis of negative 4 pi on 5. So 2 conjugate pairs, I'm going to pick either pair. Because I've got all my solutions, I'm going to choose the pair with the slightly, very marginally smaller numbers, which is the 2 pi on 5, right? It doesn't matter, you can pick the green ones, pick the yellow ones, both answers will get full marks. I'm just going to choose the 2 solutions I've highlighted in yellow. Again, you could pick the green ones, you'd be fine, you would get full marks for your solution. So once I do that, I basically identified, and I guess this is where I can do, I may as well take each of these out into my real and imaginary parts. It's going to make it a little bit easier when I expand. So if I take cis 2 pi on 5 out into real and imaginary parts, I basically get cosine. I get cosine of 2 pi on 5 plus sine of 2 pi on 5i. And I can do the same thing down here. I'm going to wind up with cosine of negative 2 pi on 5 plus sine of negative 2 pi on 5i. Now, I do have some options. I would recommend simplifying the angles, right? So if we simplify the angles, that means that cosine of a negative, the negative just disappears, it becomes positive. If we don't know that rule, I spoke about it a little bit, and I got it mixed up in a previous video. But if I have cosine of a negative angle, the negative essentially disappears. Sine of a negative angle, that negative comes out the front. So if I simplify this here, I'm going to wind up with cosine of just positive 2 pi on 5, or minus, I should say, sine of 2 pi on 5i. So I've simplified my expressions as much as I can. These are really the 2 answers that I care about now, both of these 2 answers here in simplified form. So what that basically means now is I've done pretty much most of the heavy lifting. Now I can kind of like brute force the problem using algebra, and so far it hasn't really been all that tech required for a question like this. I mean, there might be some nice answers if I take them out of cosine 2 pi on 5, but for the most part right now, we don't really need the calculator too much for this question, yet at least. So if I do this, I basically get the following solutions, right? I know that z equals 2. We said, okay, we could write that as z minus 2. I'm going to do the same idea here for the remainder of my solutions. I'm just going to write it down here so we can see. My 3 roots for my cubic are going to be z minus 2. That one was given in the question. It is going to be, we'll just do the one that I can see here, right? Cosine, oh wait, sorry, I missed my z. it is going to be z minus cosine 2 pi on 5 plus sine 2 pi on 5i. If you're wondering why the sign swap, remember my z is here, so I basically have to subtract this part from each side. I'm going to add that part to each side, so that's why I have a minus and a plus. I do the same thing for the other part as well. Wow, I'm really running out of space here. The same thing for this part here. I'm going to wind up with almost the same bracket. It's a conjugate of each other, right? So it's almost the same bracket. I'm going to just grab all of this. I'm going to shrink it down ever so slightly, and I'm going to wind up with z minus cosine 2 pi on 5 minus sine of 2 pi on 5i. So that's a lot. I'm actually just going to copy and paste this whole thing to the next page. Actually, can I take it with me? I have to copy it. Okay, copied. Nice. We're going to take this across. Let's get it out of the lasso. We're going to take this across. We're going to paste it here. All of this. That's my factorized form. But unfortunately, we are told to leave your answer in expanded form. So we have to now expand this thing. When we expand, let's just do the complex stuff. We're going to leave the z minus 2 basically just stuck out the front. Z minus 2, you are going to stay put. And I'm now going to expand this big, like, trinomial. It's basically a trinomial expansion where I've got 3 terms. So, it's still the same idea, right? It's basically FOIL. I do my first term multiplied by everything, second term multiplied by everything, third term multiplied by everything. If I do z times z, I wind up with z squared. If I do z times negative cosine 2 pi on 5, I get negative z. Actually, I'll put my z at the back. I get negative cosine 2 pi over 5 multiplied by z. And if I do z multiplied by negative sine of 2 pi on 5, I wind up with this. So that's my first term multiplied by all 3 terms over here. I'm going to have to do the same thing again for term 2. So if I do the same thing again for term 2, I'm going to be multiplying by negative cosine 2 pi on 5 by everything in my other bracket. That is going to simply just wind up with, maybe actually, I'm just thinking about this a little bit, right? I actually made this slightly harder for myself by expanding and simplifying. I thought I was being clever by doing it that way. I'm going to change my mind here slightly. Now, if you're in the exam, this can happen, right? Where you feel very confident and you're working through and you start to realize, hang on, I'm going to be multiplying cosine by cosine. I'm going to get cosine squared. It's not impossible. However, something did just kind of click a little bit. I've got, because, okay, this is what basically clicked. If I multiply cis by cis, I have rules for that. Cis, r cis theta times r cis theta gives me, I times my r's together. I add my angles. I do it really well. I don't multiply cosine and cos times sine, all that stuff together. I don't multiply that stuff together very well. So I've actually realized that by expanding each of these expressions for k equals 4 and k equals 1 has actually made things harder, and I should have kept them in cis form to begin with. So I'm actually going to fix this up a little bit. I have an eraser, right? Obviously in the exam, don't erase, like line through it and just basically redo where we left off. This z minus 2 part can 100% stay. I'm just going to get rid of this part here, okay? Now, there is a way to get to the solution, but I think it's going to be a lot harder, and it's more likely to make mistakes, and I don't want to make a mistake and have to redo everything too. That would be very annoying. So, we're going to just basically realize in the moment, hey, I can make my life easier. I'm just going to make my life easier. Again, an exam, we don't want to make a silly error. So, I'm going to put them back in the yellow form, meaning I've got z minus... Ty, please, I'm in the middle of working. Go talk to mommy. Go talk to mommy about it, okay? I love you. Thank you. Okay, I got interrupted. Apologies. My wife was looking for her AirPods. They were in my pocket. Obviously, that's an emergency. So, where I left off is I'm basically going to write this as z minus, in this case, it is going to be cis 2 pi on 5. And my other bracket is going to be z minus cis. And I'm going to keep it as a negative because I can't take the negatives out if it's in cis form. Minus 2 pi on 5, okay? I've now got rid of the trinomial thing, so I don't have to do a billion expansions. That's really nice. And I can use de Moivre's theorem to make everything a little bit Am I getting some slight lag here? I don't know. It's going to make everything a little bit easier. Okay. So that means that if I expand out now, I have z times z. That is simply just going to give z squared. I have z times negative cis 2 pi on 5. That's going to become minus cis of negative 2 pi on 5 z. Nice and easy. I get minus cis times z, and I get the same thing. I get minus cis of 2 pi on 5, positive this time, multiplied by z. And this is where it gets nice, right? I can multiply my cis parts together. Negative cis times negative cis, that's basically like minus 1 times minus 1. Multiply my r's together. That's going to give positive 1, so it's going to become plus cis. And I can now add my angles, which you guys might realize in this case here, if I add my angles, I get 0, right? Why do I feel like I've thought about this the wrong way? I get 0. It's all fine. Sorry, I just had a second where I was like, it just feels suddenly too easy. Okay, so life's good now. The expansion worked way better. I can now simply just take things out of cis form now. Probably makes the most sense. Now I've done the big expansion part and I've made my life a little bit easier. Take things out of cis form, collect like terms, and basically see where we wind up. If we can clean up the expression a little bit, right? We're pretty much there to have an expanded expression and getting the full answer. We're just going to have to tidy up some of our cis parts and see what we can wind up basically getting to. So I think like it just looks like things are going to simplify well. When you have conjugates, you tend to get things simplifying well when you start kind of putting things together. So my z minus 2 is going to stay here for now. If I tidy up all of this, I get z squared minus this whole cis part here is simply just going to become cosine of, we can just make it positive. We just explained this part before. The negative angle part doesn't really matter too much. And instead of plus, it's going to become minus sine of 2 pi on 5i, all outside of z. I can now basically do the exact same thing with my other expression for z, and I get minus outside of, I guess I'll go down a line here a little bit, right? I get minus outside of, doing the same idea, cosine 2 pi on 5, and it's just going to be actually, wait, I thought, oh no, I'm okay, sorry, brain's buffering, plus sine of 2 pi on 5i, with a z on the outside, and then cis 0 is going to become just simply plus 1. So if I do all of that, I can now, there's a few ways to get to our answer, right? And part of my brain is trying to skip steps, so apologies, I'm fumbling my words here slightly. I can basically take my z, I can multiply in as like one idea, or I could realize that essentially z is a common factor to both of these two terms. In other words, z is common to both this term here and this term here, right? So because z is a common factor to both, I can basically put all of them in just one big bracket. I can take z out as a common factor overall, and I wind up with this situation here where I get z minus 2, whoa, outside of z squared, and I basically get this big bracket where I have this minus sign out the front, right? Big bracket, I get cosine 2 pi over 5 minus sine 2 pi over 5i. And then I get the same thing where it's going to become simply just, if I minus out the front of everything, it's going to become, it's going to become plus, cosine 2 pi over 5 and plus sine of 2 pi over 5i. And then I've kind of got like this big bracket. I got a z outside of everything. In other words, I'll scroll down here a little bit so we can see. In other words, all of that is my coefficient of z, and my plus 1 is just plus 1, which is nice because it's basically like my answer for that part's essentially done. I should put a final bracket around that too. So if we have a look, I can kind of tidy things up here a little bit, right? I've got minus sine 2 pi on 5i plus sine 2 pi on pi I. So those two parts are going to cancel out. So that's gone. Instead, I basically just get cosine 2 pi on 5 plus cosine 2 pi on 5. So what I wind up with inside these brackets when everything kind of tidies up, and this is really, like I said, with conjugates, this is very common that a lot of things start to cancel out. Specifically, your imaginary parts cancel out. I wind up with z squared. I guess I can just do minus out the front, right? Just minus cosine 2 pi on 5z plus 1 is sort of 1. That's just my quadratic part. I can now multiply my z and my 2 through, and more collecting like terms, and I wind up with z cubed minus 2 cosine 2 pi on 5z squared plus z, and then if I do my second term, that becomes minus 2z squared, and then it just simply becomes plus 4 cosine 2 pi on 5z. This felt like it was going to be answered very quickly, and in the end, it really took a long time. Minus 2 on the end. I've now got, we're so close, I've now got my 2 coefficients of z squared. I've got a coefficient here and a coefficient here, and I've got my coefficients of just z being 1 and this 4 cosine 2 pi on 5z. So I group those terms, and I've finally finished, I believe, z cubed. And I'm just going to put a plus here, and I'm going to put a big bracket, and I guess I can actually make this a minus. That's probably easier. Put a minus out the front of, I'll just do this part first. 2 cosine 2 pi on 5 plus 2 outside of z squared plus brackets 4 cosine 2 pi on 5 plus 1 outside of z minus 2. I need to scroll down. Sorry, my face was blocking some of that. That is the final answer. CU question done. It honestly, like I said, it wasn't too bad. It was just like so much algebra. This feels like a tech free question from a tech free paper more so than a tech active question. But we got down to a pretty nice solution in the end, and I'm pretty happy. I'm pretty happy with that. So let's go across and do the final complex unfamiliar question. Okay, so consider the following information. I feel like this one has to be very calculator heavy. If I consider the following information, continuous random variable x. Okay, so I'm given a table with a mean and a variance. The waiting time for t minutes is given by this probability density function where n is a positive integer. I'm going to scroll down so we can read the whole question. K is going to be a positive constant. The wait time until workers receive their 5th call is collected from a random sample of 80 workers. Determine the probability that the mean waiting time for this sample is more than 16 minutes. So for the determine the probability part, that basically means you're going to have to do some kind of norm CDF in the end, okay? So because of this line here, I basically know I'm given a pretty big hint as to what I'm going to need to do. I'm going to need to do a norm CDF, Normally the way we write this is lower bound. So we wouldn't calculate upper bound. We've got our mean. I mean, I guess in this case, right, like we're talking samples and stuff. So it's going to be, I guess, X bar in this case. And then it's going to be the standard deviation. So the things I need to find are lower bound, upper bound, the sample mean, basically, and the standard deviation, okay? With a random sample of 80, like, it's probably going to be one of those things where really my mean is going to come from my expected value. And because the sample's so high, I can basically use X bar and U interchangeably, I believe, for this question. Yeah, I literally can just do this as being U in this case because, well, it's going to be an expected value question. It's kind of hinted at with the formula we're given there. So that's basically the 4 things that I'm trying to put into my calculator for my norm CDF. So if I have a look at the function, t has to be greater than 0. I know for any, we'll start with the boundaries, right? The lower bound, upper bound. I know for any probability density function from minus infinity to infinity of some function, whatever my function is with respect to x, if I integrate that, I get a value of 1. So I'm going to use this idea. If I look, I'm starting at 0. I have no idea what my upper bound is. So I'm going to basically put this function here, and I don't really care about this part because it's 0 everywhere else. I'm going to put that part of my function there. That's basically my f of x, or f of t, I suppose, in this case. And what I'm going to wind up with is the integral from 0 to infinity of, I guess I just write the whole function out, right? That is going to be kn t to the n minus 1 all over n factorial e to the minus t on 3 with respect to t. All of that is going to be equal to 1. So I've determined some expression, and I basically know now, when it comes to this part here, my lower bound and my upper bound, this is going to be 0, and this is going to be infinity at this point, unless there's no reason for it to cap, right? There's nothing told about what the upper limit of this particular thing is. It's t greater than or equal to 0, time can technically go to infinity. So there's no reason why we can't go to infinity here. So now I really just need to find my mean and my standard deviation. We are given hints around these two things here, right? I know my mean is going to be given by my expected value, and they're obviously expecting me to integrate to get that. And I'm going to find my standard deviation most likely by square rooting the variance and using this formula given here. So we're actually given quite a lot of help. Problem is, when you have so much information, how do you see all this? And that is something that takes study, practice. That's why working through past exam papers is so important, because if you can't identify what the question's asking, then doing all the study and all the textbook questions in the world isn't necessarily going to help you. So we need a bit more information, because I've just got a bunch of things. I've got n. I need to have something I can put into my my integral here. So the waiting time until workers receive their 5th call is collected from a random sample of 80 workers. So, okay, basically our sample of data, and we're trying to find the mean, right? Right, yes. From this sample, yeah. So I basically care about when we have our 5th call, and n is going to be the phone calls, right? The nth phone call. So I'm basically going to say that n equals 5. N equals 5 in this case, right? N is going to equal 5. So I'm going to get the integral from 0 to infinity of k to the power of 5, t to the power of 4. It's going to be 5 factorial. 5 factorial. Oh, wait. I did mess this part up here a little bit. Sorry. I wrote this down wrong. That was nearly going to ruin the entire thing. So it's actually not 5 factorial. It's going to be 4 factorial. That is going to be 4 factorial. That is going to be e to the minus t over 3 with respect to t. And again, I know all of this should equal 1. Now, here's where it gets a little bit interesting. It looks like we have two variables. We've got the variable k and we have the variable t. However, I have a definite integral. What does a definite integral do? Well, a definite integral is going to substitute in, despite it seemingly being impossible, right? But it's going to technically substitute in infinity in place of t, and then it's going to substitute 0 in place of t. So in a definite integral, the only variable I actually have is the letter k. Now that's really important because I need to find the letter k in order to basically figure out the rest of this problem. So to find k, I can basically now do my favorite skill on the calculator, which is going to be n-solve. I can n-solve my definite integral. I can n-solve literally what I've got written right here, because my t actually isn't a variable, because in a definite integral, I am substituting values in place of my t. So basically my letter t's are being replaced by numbers. Specifically, it's being replaced by my boundaries. So I can actually n-solve this. It can handle all the infinities. I'm going to n-solve. This is how I'm going to solve for k. I'm going to n-solve my entire integral. That is going to be from 0 to infinity. There's literally an infinity button on the calculator. From 0 to infinity of k to the power of 5, t to the power of 4, over 4 factorial, e to the minus t over 3 dt, all equal to 1. And the variable I'm solving with is k. If I do all of that, it's going to tell me that k equals 1/3. I now have my value for k. This is really important, okay? Once I've got this part, this question is legitimately quite challenging, but once I have this part, I can actually now find my mean, because I can't find my expected value when I have my variable k. The t's, like I said, they technically substitute away, but with my k as part of my integral, I needed to find a value for that so I can find my expected value. I can now find my expected value. I guess I should call it ET, right? Because it's my expected value. T is sort of my variable here. And again, it is now going to be from 0 to infinity of my variable is going to be t. In this case, we're just using the formula given to us here, which is x p of x. In this case, because my variable is t, it is t p of t. Or f of t, I suppose, in this case, right? So it's going to be t multiplied by my function, which is basically this function here, but now I have k, so I can put 1/3 in place of k. So it'll be 1/3 to the power of 5, t to the power of 4, over 4 factorial, e to the minus t over 3 dt, all equal to 1. And, actually, I guess I'm not all equal to 1, so I was just writing down what was above. Don't really need that part anymore. So I'm just finding my expected value. I could simplify this here a little bit. I think my calculator is going to have no issues with it whatsoever. But it is worth pointing out that if you are having calculator issues, you can multiply these two parts together. Sometimes it can just be a little bit weird with definite integrals, to be very specific. And you can make that 1/3 to the power of 5, t to the power of 5 over 4 factorial. That may help. However, if I type that in and I make sure I remember a multiplication sign between these two things, or brackets or something like that, another multiplication sign here, brackets, something like that, to make sure the calculator knows we're timesing, I should get an answer, right? Yeah, I should get an answer. I should get an answer here if I type into my calculator. So I was trying to figure out where I put this number down before. I get an answer of 15. Okay, so I get an expected value, or like this is essentially U, right? I get my mean is going to be 15. My expected value is essentially my predicted mean for my sample. So once I got my means equal to 15, I can now find my variance. My variance T is going to be equal to, again, we can just use our formula. It is going to be the integral, again from 0 to infinity, of T minus 15 all squared. And again, now I just multiply it by my original function. Sorry about all the swiping back and forth. I'm just making sure we can see that this is coming from our formula over here. Again, P of X or P of T or F of T in this case is just the function I'm using. The function I'm using is going to be 1/3 to the power of 5, T to the power of 4 over 4 factorial multiplied by E to the minus T over 3 all to T. Okay? So if I do that, yes, just making sure I got everything right. I didn't make any mistakes in my formula. If I type that in, I click equals, very tech heavy this one, very, very tech heavy. If I type all that in and I click equals, I'm going to get an answer of 45, which is very nice actually, and this is why it's important to keep all your values as exact as possible. An answer of 45. To find my standard deviation, I'm going to square root the variance, and that will give me a number that is approximately 0. Wait, sorry. Wait, I did jump a step here a little bit, right? I get the square root of 45. Once I get the square root of 45, I just want to keep it as the square root of 45. Okay, I don't want to do anything where I start to write out lists of decimals. I want to keep my answers as exact as possible. So I'm keeping my answers as exact as possible. I'm now going to do the part where I have to understand that for the norm CDF I'm running here, this is really going to be, because it's based on the sample, this is really going to be the standard deviation divided by the square root of n. So I know n is 50 in this case. So to find the actual, I guess we can call this S, or the standard deviation I'm actually looking for, right? The standard deviation of the sample, I suppose I could write. I guess I can just use S to keep it simple. My sample standard deviation is going to be the square root of 45. That is the population standard deviation, essentially, divided by the square root of the number of things in the sample, which we were told is 80. If I put all of that into my calculator, I get 0.75. Okay, again, you can actually keep it like this. You keep it exact, that's fine. And now I've got my upper, also my lower, my upper, my mean, and I've got my sample standard deviation. I can put all of this into a normal CDF, and I can say, okay, well, the probability that the time is greater than 16 minutes is going to be equal to the norm CDF of 0 to infinity. Oh, I guess actually I'm doing my boundaries, right? Let me have a quick think. Okay, so apologies. I was just writing down my boundaries. Sorry, my face is in the way of that. I was writing down my boundaries. This is actually going to be 16, right? Because it's greater than 16 to infinity. Again, my mean in this case is going to be 15. And I always leave things exact because I just would hate to make this type of error on the calculator. So I would just write it in like that. I click equals, and I get an answer that is approximately 0.9, which is, oh, sorry, not 0.9, 0.09 as my final solution to this particular CU. And that's the best 3 words to read. End of paper. We have completed the exam. We are done. I hope you guys thought this was really useful and or helpful. And if you guys have any questions about exams or any exam tips, if any questions about this paper or any papers really, feel free to comment those down below and I'll make sure I get back to them as soon as I can. We're going to keep doing exam videos on the channel, so if you want more specialist exam content, please share with people that also are doing specialist maths so they can see it, and feel free to subscribe as well. And I'll see you guys all in the next video. Bye!